it is going to be really easy, so give me a minute.
你已经加了，对，好，谢谢。
Okay, so this guy. Just double checking. Châu Yuxiang. Okay, got it. Wang Ziyan. Not here yet. Loic. Okay, thank you. Eric has Yang Shu. Yang Shu. Hi, come in. What's your name? Liam. Lee.
No, I am a graduate student,
Okay.
so I want to try this course.
Just sit in or adding the course?
I will if I can.
You can.
Yeah, I need your.
Yeah, I mean, if you want to take the course,
Yeah.
you can. Yeah, get a code right here. Which department are you from? Material science. Okay. So this is an undergraduate course. So if you take this one, you need to double check with your department to make sure it counts in your degree.
Okay.
Otherwise, you are just
Yeah.
enjoying the class. Okay. So Yang Shu, is he here? No. What's your name again? Sorry. Sorry. What's your name?
Yeah.
Leon. How do you spell it?
L-E-A.
N-E.
L like lake.
Oh. N.
L.
L. Okay. Sorry.
E.
Yeah, okay.
A.
Yeah. Leah. Okay. Leah. Okay. Sorry. Our pronunciation is a little different. Yeah. I will call you Leah. Okay. Thank you. Because you are basically taking an undergraduate course as one of your graduate program. So I think you can take it first, go to the department to double check whether it's gonna be considered for your graduation. And if you need my signature or someone's signature, just go get it.
Okay.
Then I think if some professor approve it, then you're fine.
Okay.
Yeah. Okay, good. So we have 24 students, supposedly. Before I start, let me tell you what this course is about. In the system, I think it's called mechanical design. But actually, exact same course in the United States is usually called design of mechanical components. How come it's either mechanical design or design of mechanical components? The main reason is because when you are designing a machine, usually you design the components. So in this course, we worry about how each component should be designed, whether it's gonna fail. So there's a lot of mechanics inside the course. So if in a machine, usually, for example, a car, when someone get into the car, the load of the person will be carried by every component inside the car. So basically, most of the components are carrying some loads. If a component is carrying load, it deforms, there's stress inside. If the material is not strong enough, it will fail. You don't want to drive a car and then it collapses, right? And you don't want to drive a super strong car and then the company doesn't make money. So a course like this basically teach engineers how to make proper designs so the parts can carry the loads and also not too expensive, not too bulky, not too heavy, lightweighted, yeah, something like that. Basically, the entire course is about this. Okay, so my name is Po Ting Ling. I'm a professor from Mechanical Engineering Department, and this is my cell phone number. In any emergency, you can call me, okay? Or if you're lonely, you can call me. My Facebook is here, so if you would like to message me, you can use this. And I have a line ID here if you want to send a line message to me. I'm happy to answer your questions. So that's basically everything about me. This is the room of my office, but I'm not there too often. So don't try to knock the door, it's not easy. Even though sometimes the light is on inside, but I may not be here. I may be somewhere having a meeting and forget to turn off the light. Yeah, so send me messages, emails to double check where I am, or if you want to find me. My email is here. I didn't write it down over there. I gave you the Gmail. Okay. So we have a TA, Tommy. This is the TA, please. He's the TA of the course. Maybe some encouragement. Thank you. Yeah. First time as a TA. Okay, thank you. Thank you. You can sit down. His room is in ME building, the first engineering building, 262, room 262. It's really hard to find. It's a small room inside a bigger room. So you need to find 260, and you need to be able to get into the room because it's locked. And then inside, there's a small room called 262, also locked. So if you want to find TA, message him. Otherwise, it's super hard to find it. Later on, I will tell you in the entire course, I may be having some meetings somewhere. I need some help from a supporting lecturer. So this is Dr. Bridges Patel right here. Please. He's my postdoc in our lab. So in some of the courses, I may need him to take over my job right here. Okay. And we do have a course webpage I will show you later on. I put many lecturing information on the page. I will do that later on. Before, so I guess we now can talk about the scheduling of the course. So this course is for GTEP students and IATP students and also exchange students or anyone who wants to take it. You're welcome to join. So on Tuesday morning this time and also Wednesday 9, 10. I know it's very early. So usually on Wednesday morning, I will put some exciting events on Wednesday, like exams, tests. So you will wake up early and come. Anyway, this is the schedule for the entire course. So I hope that kind of advanced teaching method could help everyone to learn more about the materials in this course. And based on my schedule, my plan in that project, tomorrow we will have a pre-test. So it's a very simple test, and it may not be simple, but the test is about figuring out who you are, what level you are in, and hopefully at the end of the semester we will do the same test again, you will do better. That means you learn something from the course. So don't worry, you don't need to prepare anything, and I'm not going to tell you what's in the pre-test, but there's gonna be a pre-test tomorrow, okay? And I will start to review mechanics of materials. The very fundamental knowledge for this course is about mechanics of material. That's something you can actually review. If you have taken the course, 材料力学, mechanics of material, you can get back to your previous notes and review those. I will spend some time to review those as well, and I will mostly focus on the parts that's more related to my course material. I won't review the entire mechanics of materials. Then we will focus on like a cylindrical system or a rod or a axial system anyway. Because in a machine, most of the time we do have mechanical parts that's rotating. And usually we have a cylinder and our components installed on top of this cylindrical part. That's why cylindrical shaped objects are very important in mechanical design. And that's the first component we're going to talk about. And as you can see, we do have multiple exams, and they're all on Wednesday. I set up 3 exams because I want to distribute the pressure of exams. I don't want you to prepare too much material, so each exam only costs you occupy 10 points. So if you're not doing well in one of them, you may just you won't lose too much. Okay. So first exam gonna cover whatever I talked about in the previous few lectures. Second one covers these. Third one covers these. So basically, like I said at the beginning, every component will be carrying some loads. And there are different kinds of loads, something called a static loads. It's like a pushing force, but it doesn't change with time. The load is always there. And there's dynamic loads. So if I do this, the amount of load I apply to the table changes with time. So if a component fail due to static load, it's like if I break this, it's like a static load. If the load is larger than how the component can carry, then it breaks. But for dynamic loads, you can cause an effect called fatigue. So a component can still fail due to fatigue. They have different phenomena. Okay? As you can see, besides the homework, the exams, I assign homeworks as well. So they will be, I will give you a week to complete. So from here, this is Wednesday, right? The next Tuesday midnight, you can submit it. So 1 week time for finishing your homework. Each homework occupy 3 points. Okay, in the second half of the lecture, that's where the interesting parts comes in. I will hide these columns so you can see more information in the back. Okay. On the 8th week, is like at the middle of the semester, we will focus on something called AMR. It's like autonomous mobile robot. It's a robot that we build in our lab, which means there's a robot arm on top, and we have wheels at the bottom. So it's a moving platform that has a robotic manipulator that can work complete industrial missions. Why do we talk about this? Because I want to use it as a practical example for you to make designs at the second half of the semester. You will be formed in groups, and then each group will be proposing new ideas regarding the AMR design I introduced. You can have crazy ideas, and I will also help you to provide resources to help you to build prototypes, mostly 3D printing or plastic, acrylic, wood, simple cutting or assembly. You can truly make a smaller version of the ground vehicle, and then we can truly observe or take some tests to figure out whether your crazy idea works. Okay, so after we have learned something, those are the fundamental of design of mechanical components. Then I will introduce something in practice, and then you will have a team discussion. So at the time you already are formed into different groups. We will use this time for you to work together and then figure out new ideas. So on October 31st, you need to make a proposal of what you plan to work on. On that day, I will be co-evaluating your proposal with two people. One is the postdoc Dr. Patel, and another guy is Dr. Tsai from ITRI. ITRI is the Industrial Research Institute sponsored by the government. Okay, why is Dr. Tsai involved in this course? Mainly because of the project I mentioned. So we truly want someone that is from the industry to come here and then give you useful comments. And we work on the AMR project together. That's why I invited him. So on October 31st, you propose it. Then you will use some of your personal time, work with my TA in the lab, and then start to build whatever you want to build. Afterward, I will keep on giving you lectures that could be helping on your project. For example, the finite element. Finite element is a numerical method to estimate how components deform under loading. So that will help you to figure out whether a part is properly designed. So you will learn how to use finite element software. But before that, you see something called interview 1, interview 2, and 3. What are those? So like I said, I would like to introduce advanced teaching technique, and that technique includes personal interviews. So I will be interviewing every one of you and figure out why you choose this course. Of course, you may say it's a requirement. I don't really want to be here, but it's required. Maybe there are some other reasons behind that boring answer, right? And after the interview or personal discussion, maybe I hope that will encourage you to learn more about the material, or you can have it give me feedbacks about what you are looking for. And maybe later on I can fine-tune what I give you, or I can give you some suggestions in the interview. So that's a really unique way of teaching. It hasn't been used very commonly in engineering department. However, that's a really common way of teaching in management department or some other departments, like a biomedical department. So it's a really unique way of teaching in engineering. So if I want to do that, it's impossible for me to interview every one of you in one class. I will be separating each of you into 3 groups. I will use 3 lecture time, and then on that particular time, I only interview 1/3 of the class. So over here, you will see numbered 1n plus 1, 3n plus 1, 3n plus 2, and goes from 0 to greater numbers, integers. So basically, first one and then plus 3. The 4th one, so it jumps by a gap of 4, of 3. So over here, I will be numbering everyone like this. So those are the numbers. So on that particular day, I will be interviewing the first one, the 4th one, plus 3, 7th one, plus 3, 10th one, like this, okay? And this is not the final student list. So you will know where you are after maybe next week. So on the day that you are going to be interviewed, we will find a proper time, proper time slot and proper location, maybe here or maybe somewhere in the campus, a smaller environment. I can buy you coffee if you drink coffee, or buy you tea. So it's a really relaxed environment, no pressure. And for the student who are supposed to be here, of course, you need to be there. And for the rest, it's your breaking time. You don't even need to come. So 2/3 of the student won't need to come here in the class. If that's the case, then you will be missing 1 hour of lecture. In fact, you don't, because we need to do prototype project, right? So you actually use some of your personal time to complete the project. So it's okay that you miss some of lecture time, because you will be doing more when you build a prototype with your teammate. So over here, this is interview 1, interview 2, interview 3. So each person only come to interview once, and that interview counts as 5 points. Okay, so don't miss your interview. Among the following weeks, we have design for gears, bearings, or some commercial-ready parts or well-known parts, commonly seen parts, gear, bearing, screw, belt. How come only these 4? There are even more. There are so many available parts, known parts, but the lecture time is not enough. So I want to use these 4 to guide you through how to make mechanical design in specific parts. Once you know the trick, later on in the future, when you are working for a company and they ask you to design some other kinds of parts, based on the experience of this course, maybe you could learn by yourself by reading some books. Okay? So even though I add 10 more lectures, it's impossible for me to complete the mechanical design of all kinds of parts. It's impossible. There are way too many kinds, hundreds of kinds of parts. Okay, so I will just only teach you the fundamental ones. After the proposal at the end of August, on 21st of November, you will be giving progress report, like making team presentations. You can prepare PowerPoint, you can bring whatever you have at the point. Right here, when I say with and by, the difference is with includes me. I evaluate with them. When I say by them means that doesn't include me, only by these two. On this particular day, I think I'm traveling for an international conference or having some important event outside of campus. So I cannot be here in, I think I'm in Japan or somewhere. I cannot do these two. So Dr. Patel and Dr. Tsai will be evaluating your progress report together. And a day after, there is a second team discussion hosted by Dr. Patel. So on that day, because after your progress report, they will be giving you important comments. You may want to make small changes. So the day after, 1 hour, we can have more discussions. So Dr. Patel will guide you to have a meaningful discussions so you can have a better improvement. Then lecturing, interview, lecturing. So here when I say prototype check, it's not, there's some points here. You need to be here and we will check your design and also give you comments. But you don't need to make presentations. Okay, and during the day you can still keep on working on your project, but nothing serious on the day. So for this very end of the lecture, we don't want to occupy you too much. We just want you to focus on your design. And we set us several milestones. So if you are able to give us some progress on the day, and if there's no more comments, then you're done for that particular mission. So it's a very minor check compared to other bigger events. But anyway, we still check on your prototype progress. Finally, on the 19th of December, that's the final day, final big event, where you want to have your final presentation with the prototype you have. And on that day, all of myself, Dr. Tsai, and Dr. Patel will be here to co-evaluate your final performance. And after your presentation, that's the most point that is included in the entire course, 18 points. So once it's finished, there's one more thing that to be done, that is the post-test. Remember, we have a pre-test. Now we were having a post-test a day after, and of course some questionnaires. And from scoring, you can tell the total is 100. Okay, total is 100. So being here, you can get 10 points. Doing some homework, 9. Exams 10 for each. Project is the biggest. Everything related to the project is the biggest. So please pay attention to the project. Okay? That's pretty much everything about the course. Any questions so far? Anyone wants to drop? Okay. It's okay to drop the course. Now, as I mentioned, there's a web page right here. So if you go to the web page, it's gonna be a page like this. It's the web page for my lab. And I actually put multiple online resources on the internet on this page. As you can see, I have previous lecturing videos. I have lecture notes. Let me show you just a particular one. This is a previous PowerPoint. Do I use the same one again? Of course I will. So I may be making adjustments, but if I don't, it's basically the same PDF. That means you can already go ahead and click on those hyperlinks and start to study what's included in the course. And if you want, you can check on those videos. See? But you know, some of the videos were poorly recorded. Like this one may not be excellent. You of course it doesn't play the audio. But you know, when I do presentation like this in the past, I usually turn off the front light so it's quite dark. But this year, I think the entire school updated their system, so we don't really need to turn off the light. So I believe this year's video will be having better quality. Anyway, I think the video still is okay because I provide the PowerPoint, I provide some videos. This is a better one. I think I made. I have been making videos multiple times for same material. If you don't like this particular video, you can try the other one. Because you know, every time we lecture the same material in a different way. Sometimes I did good, sometimes I did bad. Okay, anyway, those are the resources available for you. You feel free to check on them. If you plan to take some other of my courses, I do the same for other courses, optimization as well. Yeah, that's basically 3 major courses I teach right now. Okay, that's everything. I think that's everything. Oh, how about grouping? Do we do grouping today? Do you want to know who's your teammate today? I think we can. Do you want to group by yourself or randomly? How about random? Do you like random grouping? The main purpose of random grouping is to make sure you have people from different countries. Otherwise, Taiwanese here, American here, Indonesian here, you know, you all use your own language. Yeah, so I think random grouping will be better. Okay? Okay, so for whoever is here today, we will group you guys first. And I know some of them are not here, some of the students are not here. We will put them into empty spots later on. Okay. Let me quickly write a code right here. By the way, will Adrian take a course? Adrian, okay, so I think I will include him, because we are sure he will be here. But I'm not sure about Wang Ziyan and Yang Shu. So I think I will not include them for now. Later on when they show up, I will put them into the empty spots. Okay, so those are random numbers. I'm going to sort them. And how many teams you have? 6 teams? Okay, I think 6 teams. So whoever get together in one box, they are in one team. So let me show you what I mean. I start to make boxes of 4 slots. I'm sorry. Okay, and then I will be sorting you guys in terms of the random number, and every 4 people will be placed into a box, and whoever is placing a box is in the same team. Just testing, not yet. Okay, just testing. Okay, this is the test. So just the test, not the real deal. Okay, not yet. After another test, if I type 1 and go down, it changes again. Now if I erase this 1, all the random number changes one more time. So this is the real deal this time, okay? I erase the number 1 and that's it, okay? We have recording, so no tricks. Okay, here's the final grouping. I will copy paste this, that's who your teammates are. So purely random, I know no one, okay? No tricks. So I will copy the grouping results here. Okay, that was a paste. Okay, so the two students here, you may be working with the two exchange students, the two missing students. If the two missing students are not coming, then you have a smaller group. Okay, I can put a TA in the group. Anyway, question?
Yes, I can't find my
You don't have your name here? No? What's your name?
Arthur.
Say again?
Arthur.
I miss you. Okay. Then can you be here at the bottom?
Okay.
Yeah, thank you. Did I spell right? Arthur? Okay. So I think when I built this, I forget about you. I'm sorry. So we do have 25 students. Okay. So I don't need these anymore. Okay. Before you go, maybe you would like to know who each person are. So when I call your name, can you stand up? Edvando, Anna, Adrian, Eric, can you stand up? So you guys know who you are? Four people?
Ardian is sick.
He's sick. Okay, got it. So you three and the sick Adrian are in the same group. Okay, thank you. Okay, you can sit down. Zhang Chen, Hans, Yan Fu, and Fan. So you four are in the same group. Okay, good. Francis, Kenzie, Yue Zhe, Zhiwei. Can you stand up? Okay, you four are in the same team. Loic, Junchen, Ke Yuan Lei. Where's the other guy? Oh, he's here. Okay, thank you. Good, you four are in the same team. Leah, Bing Yi, Linda, and Ren Wei. Can you stand up? So you're the lucky team has 2 girls. Okay, please sit down. Okay, you are in the same team. Xinxiang, Yu Xiang, and Arthur. Okay, you 3 are in the same team. Okay, thank you, great. You don't need to do anything at this point. Just make sure you know who each your teammates are. You probably will begin to work together at the middle of the semester. Okay? That's it for today. Any questions? Any other questions? Does anyone would like to buy a textbook? No? Okay, I will tell you which book I use. So it's called the Shigley's Mechanical Engineering Design. Okay? So he's like, if you want to know who Shigley is he's a, see right here, he's a very well-known contributor in mechanical design education. So this, I think, is already in the 10th edition or even 11th. If you get any one of these, any edition in any language or any unit, they have English units, they have the standard units. No matter which book you got, it's fine. Is it necessary? I would say no, because I don't truly follow the book. I follow my notes. But I highly recommend you to get one, no matter what edition it is, because it's a really useful tool book. In the future, when you design, the book has so many information in there. It's a very important book in my career at this point. So I really recommend you to get one. For example, you can go to the used book market and find one. I know there are many people trying to get rid of this one. It's too thick, too big, okay? So it's really easy to get a used one, okay? Or Amazon, definitely easy to get. Anyway, that's the book I use. I know there are some other mechanical design books, but this one is the most famous one. Okay, if there is nothing else, that's it for today. Bye bye.
FB Chrome.
Say again.
FB Chrome. I have already put on her.
Sorry. We do have we have a Facebook group. Hold on. This is Naomi. Hold on. Okay. So please join the Facebook. Why do we do that? We post lecture information on Facebook instead of, actually we do post on Facebook and Moodle as well. But I'm never on Moodle. I don't use Moodle. My TA helped me upload information on Moodle, but I rarely or never go to Moodle. I use Facebook. So I'm sorry, I'm an old man. I don't post on Instagram or anything else. Just Facebook. So, for example, there are important information about a course, they will be posted here. Like what's included in the exam, something like that. Here is a exam sample you can study, something like that. Okay, that's it. I'll see you tomorrow, and if you still have questions, you can come here. Okay, bye bye.
Saw you guys trying to relocate this. Later on, upload the Google Sheet to Facebook.
OK，好，你们要几个？好，这样子。中餐吃啥？同事。
Would like to, if you want to sit in. Let's see what I cover.